All right, this is episode 2 here, so it's good. Informally kind of hearing from you guys. Even though it's not traditional, we're not seeing each other, but it was good communicating with you guys and kind of seeing what you guys are going through with this whole quarantine thing. The overwhelming positive I got from you guys was that you are. My chicken in the back over there, one of them. That you guys are getting more sleep. That was positive. You guys are able to sleep in and stuff like that. It's definitely a plus. I have kids. I have a 1.5-year-old who doesn't really let us sleep that late. And even so, I remember when I was your age sleeping to, uh, you know, 11 or noon. I can't do that anymore anyway. So I wake up same time no matter what. But definitely a bonus not having to rush out of the house, having breakfast with the family, and then the overwhelming negative is going out and seeing your friends and stuff like that. So it's definitely negative. It's definitely getting old, staying cooped up inside. But hopefully, the last, this Monday, this Tuesday, were really nice. Hopefully, you guys get outside. Go on a run, go bike ride, do something. Go do something outside as long as you're social distancing, and hopefully you guys are well. And what we're going to get into today is seasons and the reason for the season. This is the biggest misconception in science. So hopefully you guys respond and let me know like what you thought the reason for the seasons are. And again, this is one of the biggest misconceptions in all of science. It's something you go through your whole life, right? Especially living in Long Island, it's a very seasonable place. Our winters are cold, our summers are warm, right? It's not like we're living in San Diego, where sometimes I wish we lived in San Diego, where it's 70 and sunny almost all year round. We're dealing with different climates, and you experience it, and you might not know why. You might have some incorrect assumptions why. So what I want you to do right now is you're going to pause this video. You're going to go to the other video that I posted where they go to a Harvard graduation. It's kind of dated. I think it's probably like early 90s when they did this. But they asked all these Harvard graduates and professors, why do we have seasons? What's the reason for the seasons? So they asked, this is the most prestigious university in the world, supposedly the smartest people in the world, and they're asked one of the most basic things, an observation that they go through their whole life. They've gone through science classes, upper level science classes, and look at it, and the majority of them get it wrong. You might have had the same answers that they had as why do we have seasons. So I want you to pause this video, look at that one, look at their response, and see if it matched up with their response. So do that now, and then you can replay this when you get back. So after watching that, you probably saw that a lot of them thought it was the distance, right? When we're closer to the sun or farther away from the sun. And the reason that people think that is because they combine two things, right? If you're close to a heat source, your experience, if you're closer to a fire, right? I got my fire pit right behind me. If I get closer to that fire pit, it's going to get warmer. If I'm farther away, it's going to get colder, right? If you're closer to the heat source, warmer, farther away, it's colder. And also we learned during Kepler's laws in astronomy that if you're closer, all orbits are ellipses, and sometimes they're closer to the sun, and sometimes we're farther away from the sun, right? But has no bearing on our seasons, right? So we're actually closer to the sun in January. That's when we're closest to the sun. So it has no effect. The eccentricity of our orbit and almost all the planets' orbits is very slight. It's very, very, very slight, right? Ours is 0.017, I think. Venus is 0.007, so it's pretty negligible, the shift in distance, right? Some orbits like comets are significant, Pluto significant, Mercury's kind of significant, but ours isn't, right? So what is the actual reason for the seasons? And I put this in the notes here, right? The reason for the seasons, right? And I'm reading it right off of what I wrote to it, right? It's varying intensities and durations, right, of insulations due to Earth's 23.5 degree tilt. So our orbit is tilted 23.5 degrees, and that's actually from when the moon was formed. They think that a large Mars-sized object hit the Earth. We were spinning upright. It tilted us 23.5 degrees. So what does that mean? Sometimes you guys might saying, oh, the tilt, right? But why? What is the tilt? If I tilt, I don't all of a sudden get hot. I don't all of a sudden get cold. What does the tilt have to do with anything? Well, it's the intensity of insolation. So right now you're probably noticing it's getting warmer, right? And why is that? Well, the reason is because the sun is higher in the sky, right? It's more intense. Think about shining a light in your eyes. If I'm shining a light Here, it's not going to hurt, but if it's directly in my eyes, it's going to be more intense. It's going to hurt. That's essentially what it is. The sun is higher in the sky. It's more direct. That's why it's warmer in the summer, right? It's when the Earth's northern hemisphere, we're in the northern hemisphere, is tilted towards the sun, and the southern hemisphere is tilted away. It's not distance, it's intensity. The days also get longer, right? Every day, it's about a minute, give or take, on each end. The sun rises about a minute earlier, sets about a minute later every day. So the days are getting longer until we hit June 21st, which is the peak of the summer solstice. And as some of you guys probably know, our seasons are flip-flop. So the southern hemisphere in Australia right now, it's fall, and then it's going to go into winter, whereas we just hit spring, the beginning of spring, and we're going into summer, right? So what does insolation mean? That's the key vocabulary word. It's not insulation. It's not the pink stuff in your attic, or you help your dad, you get all itchy, right, with that fiberglass stuff. It's insolation. Insulation's with you. Insolation, it's in the word. It's incoming solar radiation. It's just the sun's rays is what it means. So that's all it is. So it's the intensity, how high the sun is in the sky, right? In summer, the sun's very high in the sky, right? And in winter, it's lower in the sky, and it's how long it's out for too. And that's the same reason if you're going to vacation, you're going to go on spring break, you're not going to go spring break higher latitude. No one's going spring break to the North Pole, right? That's a high latitude. You're going to go to a lower latitude. You're going to go towards the equator, right? You're going to go to Florida, right? Maybe you're going to go to North Carolina or something like that, right? And this is my daughter here. Say hi, Addison.
Hi.
All right, we're talking about the seasons. What's your favorite subject, Addison?
Science.
That's right. Represent science. All right. So I lost track of where I was. But you're going to go to a more southern latitude. That's because the reason Florida is warmer than New York is because the sun is higher in the sky for the majority of the year, right? It's at a lower latitude, so the sun is higher in the sky. So that's why that is. The closer to the equator you are, the warmer it is out. All right. So I want you to kind of look at our class notes, right? And we're going to fill out the dates, the latitude direct array, the hours of daylight, the hours of darkness, sunrise and sunset. And I also want you to take out your reference tables and look on page 4, page 5, because some of these latitudes are listed there as well. Right. So for the spring, and we're going to write this down and fill it out. The spring, and we're going to kind of keep it simple. All the dates, the month dates, are multiples of 3. And the days, they can vary and go from the 20th to the 23rd, but let's keep it the 21st. So the date for the spring is March 21st, 321. And it is the spring equinox. And where is the equinox? The sun is directly overhead. Where do you have to stand to have no shadow? That is at 0 degrees, equinox, equator, right? The hours of daylight on the spring equinox, we have 12 hours of daylight and 12 hours of nighttime. Right, so 12 hours daylight, 12 hours darkness. And where does the sun rise? It rises exactly in the east. So I'm pointing east right now, right? It doesn't come directly overhead, right? It's a little bit to the south, and it sets in the west. The sun is never directly overhead in New York State, right? You have to be in the tropics between 23.5 degrees north to 23.5 degrees south for you to have no shadow at noon, for the sun to be directly overhead, right? So summer, the date, as we mentioned before, is June 21st. The latitude of the direct ray is 23.5 degrees north. That's where you have to be at noon for the sun to be directly over your head, right? The hours of daylight for the summer solstice, we get 15 hours of daylight at our latitude, right? And what does that mean? We get 9 hours of darkness, right? So that's when the sun's, you can be outside at 8:30 at night and the sun's still out, right? The sun rises, it actually rises in the northeast, it curves, it's never directly overhead, and it sets in the northwest on the summer solstice, right? The fall, that's another equinox. I'm going to fill this out. That is on September 21st. It's an equinox, latitude direct ray is 0. Hours daylight, hours of darkness, equinox equal, it's 12 and 12. The sun rises in the east and sets in the west, right? And then the winter, that is the December 21st, latitude direct array. It's 23.5 degrees south. That's why the southern hemisphere gets summer. When we get our winter, the hours of daylight here, we get 8 hours of daylight, right? It's kind of a bummer. I know, like during wrestling season where we go in, it's dark, and I'm not getting out of practice. We're not getting my car till 5:30, and it's dark when I leave, so I don't really see the sun during the winter. The winter sports athletes can probably relate, right? And hours of darkness, 15 hours, right? Hours of daylight is 8, and the sun rises. It rises in the southeast, right? And it sets in the southwest. So it's not out as long for us, right? So there are some interesting things with that. If you're above the Arctic Circle, 66.5 degrees, right? If you're hanging out with Santa during the winter solstice, you get 0 hours of daylight. And if you're in Antarctica, you get 24 hours of daylight during our winter. It's their summer. And opposite, on June 21st, actually have summer solstice parties where the sun doesn't go down, right? So if you go to, Alaska, you're above the Arctic Circle, the sun just basically kisses the horizon. It doesn't go totally down. You get 24 hours of daylight around summertime, around June 21st. And if you're in Antarctica, you get 24 hours of darkness. That's pretty crazy, right? If you live in an area like that, there's a lot of people that buy blackout shades are a must if you're living in Alaska, right? So going forward for Friday, first of all, I want you to play with that link I had on the sun's path, the Astro UNL one. That shows what the sun's path is during the year and what happens, right? So I want you to play with the different dates, the different latitudes, see what the sun does, the sun's path. So for Friday, you're going to have a short castle learning. This is a 15-question one, right? It's not going to be the 40-question one, right? We're going to save that for next week. The 15-question one, right, you're going to do, it's just on seasons questions, right? It's going to be entered in a grade. So take your time, use all the resources, use this video. I want you to also watch the other video that has animations with it that kind of explains a little bit better. I'm trying to learn today how to do some notebook stuff while I'm talking so I can kind of go to a notebook and do some animations myself. But watch that other video, right? For bonus points, I'm trying to bring up what I wrote here. All right. For bonus points, I want you to ask your parents, right, or guardians, what are the reasons for the seasons, and post their responses. And if you don't want to embarrass them, you can just private message me. But you get I'll give you 2 bonus points if you go ahead, and I'll go in the extra credit category. If you ask them what's the reasons for the seasons, and if they get it right, congratulate them. If they get it wrong, I want you to explain to them why we have seasons. Very important we know this, right? I feel very silly if my daughter here asks me why do we have seasons, and I explained it to her incorrectly. It's something I've experienced my whole life. It's a very basic scientific concept, and now some people have the same understanding as people did thousands of years ago, just kind of making things up, as to why we have seasons. So it's very important that we know. So that's what we're going to be doing. That's the lesson today, right? I want you to look at that stuff. I want you to play with that animation. I want you to watch all of the videos, right? I want you to fill out that little document that I had in the class notes, right? That has all the stuff. Fill it out as we went through this video, right? Do the castle learning, do the 15 point castle learning, and then if you want to do the extra credit, you can do that as well. So I hope you guys are doing well. As always, contact me with any questions you guys have, and we'll keep this going forward. All right, hopefully you enjoyed the weather. This is Tuesday, so hopefully you enjoyed the Tuesday weather. All right, Wednesday's supposed to not be as good. All right, talk to you guys later.